So we did this. Let's look at this. Okay, so this is testing for a substring with the in operator. Just know that this is an operator. It's not the preposition in of English. It's an operator. It's called in. Okay, let me put this on. So that's the in operator. Okay, right here, right here. In, that's an operator. So when used with strings, the left operand of in is a target. The left operand is a target. The right operand is the string to be searched. So it returns true if target string, if the substring is somewhere in the searched string, or false otherwise. Okay, so let's look at this code, right? Look at this. Okay. So file list. This is a list. We will dive into this more in chapter 5, but I told you about this. So a list is with square brackets. Okay, this is a list, right? And within it, you have different items. So 3 strings separated by a comma. So this is a list. And here is the for loop. For the keyword, file name is simply a variable, okay? In file list, this is this list, right? That's that. Okay, so for file name in file list and colon, if this is the target, this is the substring, that's the target, right? On the left-hand side, if this text, this substring is in file name, so this file name will go through each of the elements in this list. The first time it will be this. The second time it will be this. The third time it will be this. It will go through them, okay? If text is in this file name, then print it out, file name. So the output will be this, okay? Let's look at it. I have it here. Okay, so file name, file list, right? Okay, that's what we just had. I'm going to run it. And you can see those are the things that are printed out, right? So that means this is in it. Well, if I change this, let's see, how about if I change it to PPT? None should be printed out because it's not in it, right? So nothing is printed out. If you have my, let's use my, see if how many files have the word my, okay? And you have 2 list items that have the word I, right? My in it, my, and my. Let's put your there, okay? You or your, it doesn't matter. So there should be only one file name. So that's what this means, okay? And if you change this file name to simply name, can you do that, everybody? Can I do this? Change file name to simply name. Is that okay?
Yes.
Yes. Yes. Okay. Okay, Caitlin, did you answer or did someone else answer?
It was me, Mac.
Macreen. Yes, it's correct. Caitlin, can we do that?
Yep.
Yes, but what do we have to change? How do we make it work? As is, it won't work. Macreen, you answered the question too, both of you. What do we need to change to make this work? This will not work.
Change the file name that's underneath the for loop. I mean the for statement.
Yes. Okay. Yes. This is change this and change this. Okay. The reason is when we say name, what are we referencing? We are referencing each of the element, the string in this list. Okay. File list. Notice this is the file list. This is the pool, and that is the file list. variable, right? And this is an element in this list. So when we say for name, remember this for loop, it goes through each element in the list, right? So name, the first time references this one, the second time references this one, the third time references this one. So you are asking if that word is in this one the first time, and the second time it's asking if it is in this one. The third time it's asking if it is in this one. So this is each element you are asking if U is in that element. And then if it is in, you print it out. Okay. And you can see it's what that says, right? Any questions about this? So can I change this to F?
As long as you change the other stuff in there as well.
Yes, exactly. Okay. So just know these refer to that, right? Okay. So that's that. Any questions about this, everybody? No questions? Let's go to the next page, okay? Testing for a substring with the in operator. So here, everybody, this is a list. Notice this is a list, okay? You have the square brackets, it's a list, and within it, you have several strings, right? Several strings. And here we are saying, okay, it doesn't have to be a list. It can be a string also. So here is the code. For I, this is simply a variable. In, that's the keyword, operator, name, which is this string, right? And this I will go through each character because it's a string. A string is a sequence of characters. So it goes through each character. And it says if that character, that specific character is less than S, then print out that character, right? Okay, let's look at it. I have it here also. So I'm going to, this is a great way to test your program if you don't want to do all the testing at once. Okay, so this is this, right? Let's run. And it prints out all the Shakespeare except S. Why? Because this S is not less than this S, right? Remember, uppercase letters came before lowercase letters. Uppercase letter A is the decimal value of 65. Lowercase a is the decimal value of 97. So uppercase letters are less than lowercase letters. So this is less except S. S is the same, right? They are all lowercase letters, but they all appear before S. So you print out only that one, you print out that. Okay, let's see. If we say, let's use upper S. Okay, if I is less than upper S, print it out. And let's see what is printed out. Nothing. Why, everybody?
Because the uppercase comes before the lowercase, and
yes. Yeah. Yes, because uppercase letters come before lowercase letters, and this is equal, so it's not less than, and all of them come before, after S. So this condition is not met. Nothing is printed out. Okay, if you do T, I will just do a random one, and you can see all of them come before T. That's true. How about B, right? Okay. And so these three letters come are less than B. Okay, that's this. Now, if I change this to character, what else do I need to change, everybody?
the I after it, or the I after if, yeah.
Yes, this has to change. What else?
The I and after the print statement.
Yes, yes. So just to show you that that's just a variable. Whatever name you use, right? You need to make sure you use it correctly. Okay, it's the same thing. So once again, this references each character in this string. Okay, and this is the string name. In this one, this references each element in this list. Each element in this list. I'm looking at this one. Okay, it references each element in the list. And this is referencing each character in the string. Okay, and so that's the string reference name, and this is just a variable. Any questions about this, everybody? No questions? Okay. I'm going to let you do these two, do the first one, given the following statement. Okay, this is, everybody, this is a list name because this is a list and you have 5 items there, right? Use 3 for loops. I want you to use 3 for loops, okay? With the in operator to print out each list item that contains the word. So print it out if it has the word in it. And then another for loop if it has y in it. Another for loop if each item has, if the item has o in it. Let's do this first one first. I will give you 5 minutes to do it, okay? Oh, I need to, it's so small, but okay. So that's that for I in words. If words in I, yes, 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 very good. Let's run it.
Good job, boss.
So this is okay. Okay, if you separate them, it would look, it would be more understandable. Omkar, good. So move this screen to the side, Omkar, so that we can see your code. Okay, good. So if you look at, if word is in I, you have my word, your word, his word. So it should be my word, your word, his word. That's correct. The second one is Y, and you have my and your, right? The others don't have Y. And then you have, if O is in each word, is in a word, then you print it out. Okay. So that's very good, Omkar. Thank you. And that's how I'm going to record this. Okay, move that screen a little bit, Macron. Yes. Okay. So this works, but it's it does it many times
Yes.
because
It's underneath the 4.
yeah. Okay. If A in N. So that goes through each character. And so it really doesn't work this way because N is a single character, right? And you are saying if N is in it. So that's why it doesn't work. So it says true and it gives you, it prints out all that many times. So instead of using the in operator, what else can you do? Let's look at this. So you declared a Boolean variable if A is equal to false, and then if A in text, you use the in text, okay. Then why do you have to do the I, right? Okay, I think this will work, but Yeah, you have to do the I in text because it's a whole string and you want to go through each character. Okay, okay, that's good. That works. That's one way of making it work. You declared a Boolean variable, right? And if it's in it, you set it to true. And if it is true, you print it out, the letter, print it out. And if it's not true, you say it's not in it. Okay, and notice everybody here, what Yang did was his string started with double quotes, and inside he can use single quote. If he uses double quotes, he has to use the escape sequence character, and I think Macron used that, which is great. But here, because he used double quotes outside for the whole string, he used single quote for the A. Okay, very good. Okay. This is what I did. Oh no. Oh, this, yeah. Oh, okay. Take this off. That's what I wanted. Okay, so this is the text. And for C, C represents character in text. So we go through each character, right? If that character is equal to A, print out yes, and break, get out. Otherwise, you got stuck in it and you keep printing. So you keep doing the things. So if it is in it, you get out. If it's not in it, it goes through each character, right? And if it's not in it, it will go back to go to the next one, go to the next one. And at the end, you just print out not in it. Because if it is in it, it will print out yes and get out. Then this will still be there, right? Yeah, okay. So I have to use the else, I think. Otherwise, this is a separate statement. It will always print. Okay, let's run. Not in it. So I should put a break here also. No, that's not right. So originally, what I did is correct then. Okay. I did this before class. Let's see. Not in it. That's correct, right? But if I change it, if I do this, not in it will be printed out also. So let's solve this problem. This is, I'm going to pause, resume recording. Okay, let's look at data encryption. So this is the one. Okay, we will do this next time. So it is easy to observe data crossing a network. And some of you are network administrator are training to do that. Some of you are cyber security. So you deal with the network all the time. A network is a very, very interesting field among the computer science fields. In computer science, you have database, you have software development, you have network, those are all, and now you have cyber security. So these are all the different fields, different divisions within computer science. And network is one strong, one important one, right? So data goes through the network. An attacker may be using sniffing software. That means it sniffs at your data and try to crack it, hack into it. Data encryption can be used to protect information transmitted on networks. Many protocols, HTTPS, this S means security. Okay, so HTTP is simply hypertext markup language protocol. Hypertext transfer protocol. I taught network a long time ago. So this is security. That means it's secure. One or more keys are used to encrypt messages to produce ciphertext. So and to decrypt it. Example is Caesar cipher. So Caesar cipher is really the very first encryption program. Actually, it's Julius Caesar who designed it. when he was in war during the ancient times before BC, right? Or after BC, I forgot. But when before, he was sending messengers to, in between his forces. And if the messenger got caught, then his message would be gotten by the enemy. So he designed a Caesar cipher, which is just like this. So we will look at this. And he is the first one to use this. This is called a substitution the scheme cipher. Okay, so this is his actually. That's why it's called the Caesar cipher. It replaces each character in plain text with a character a given distance away. Okay, so if the string ABC would be DEF if you say I'm going to skip 3 characters. So A would become D, and B becomes E, and C becomes F. That's called the Caesar cipher. Okay, so this would be encrypted as this, because if you go 3 places, it becomes L. N goes 3 places, it becomes Q. So that's how that works. Okay, and if you look at this, this is the plain text. This is the cipher text, right? Plain text A is 97. You add 3 to it, it becomes D, which is 100. Because remember, each character has an ASCII value. Lowercase a is 97, and you add 3 to it, it becomes 100. And B is 98, you add 3 to it, it becomes 101, and E. So that's how you encrypt your message. You can actually use this now, write a program and use this method to encrypt your password. Who would know, right? This way, no one will be able to hack into your system, your account. So this is the same. Now you are decrypting it, right? Oh, this is still encrypting. When you decrypt, you simply move forward by 3 places, -3, it becomes 97. So this is how the encryption and decryption, very basic and the very first rudimentary, really, cipher cipher algorithm works. Nowadays, it's much, much more complicated, and you will learn that gradually. Okay, a more complicated one, and which you can use to encrypt your own password, is that you can use different lengths. Give yourself a number, 2, 5, 6, 1, 2. If you use this to encrypt the first character, this to encrypt the second one, the third one, the fourth one, the fifth one, and then come back to use this for the 6th one, the 7th one, the 8th one, etc. Move 2 places, 5 places, 6 places, 1 place, 2 places. So this would be your key, and then you just move your characters around and no one will know, because this is a key only you who knows, right? So that's one thing you can protect your password. Okay, but this is the cipher algorithm. Do you understand this, everybody? Or did I talk too fast? I don't think so. Do you understand this?
And so is the Caesar cipher, is that always +3 distance, or
No,
does that change?
no.
Okay.
Originally, when he used it, yes, but it doesn't matter. You can increase by 4 places, -1 places, yeah, not just 3. But an enhanced version would be this. Instead of moving each character by 3 all the time, because it's easy to hack. So you have a key, okay? And then you will move the first character by this many places, the second by this many, the third by this many. That way, as long as your key is private, no one knows what your password is. No one knows how to decrypt it, right? Okay. Any other questions? Okay, now let's look at this. Let's look at these 2 functions. Odd, this means ordinal. It will give you the ASCII value for an ASCII character, the decimal value for an ASCII character. And this is CHR, this is character. This will give you the character for an ordinal value. Okay, let's look at this. So close this and just review it. Python shell. Okay, for example, you say odd, what's the value of, what's the, ordinal value of this character A? It gives you 97, right? Ordinal value of uppercase A, it gives you 65, right? Ordinal value of dollar sign, it gives you 36. So each character has an ordinal value, and that's how you get it. A space, it should be 32. Okay, and then character is the opposite, it's the inverse, right? So I give you 32, give me the character, it will give you the space. Okay, I give you 112, 112. It gives you the character P. So that's how you do that, okay? And here, I put this here so that you can see the ASCII values and their characters, corresponding characters, okay? This is the ASCII value. This is the hexadecimal value, which you don't have to worry about. What is this? I forgot what this was. I really forgot what that is. That's the octal. I forgot what that is. Okay, so this is the this is the decimal value if you look at it. Okay, that's the hexadecimal. What is that? I forgot. Okay, now let's look at. I put that there. Now I forgot. Okay, now let's look at this file. Okay. This is plain text. This is asking the user to enter something. So for example, if the user entered this, right? That's the user entered. And the distance is equal to whatever the user enters. So this is asking the user, how many distances do you want to shift your characters? And the user entered 3, right? So now you declare this code and assign an empty space to it. And then using this for loop and the in operator, CH, that represent each character in plain text. That's what you entered. That's here, right? So the CH will represent each character, the first one, the second one, the third one. This is what you entered, and you get the odd value of each character. So for I, it will get what? For I, it will get 105, right? So that's that. And then the cipher value is equal to odd value plus the distance. So it's 101. For I, the system will give you 105. You add 3 to it, that becomes 108. And if cipher value is greater than the Z value, you will come back, loop around, okay? So if it's greater than Z, you come back because you want to stay in it, okay? So if that's the case, you will do this plus the distance and minus this. This is just the formula of how you do that, okay? You come back, you come back to A. And then code plus equal to whatever this value is. You are trying to get a decimal value, right? If it's greater than Z, you want to get a decimal value coming back, loop around, loop back to A, and then you will convert it to a character and add it to code. So that would be, the first one will be this, right? You add 3 to it, that would be this. 105 plus 3, 108, it will be this. And that's the first one. That's how that works. Okay, and eventually you print it out. Notice that this is the string concatenation there, right? That's the string concatenation. Look at this code. I want you to see if you have any problem, if you have any questions. I'm going to pause recording. I don't know if you understand this part, so I will just do one example. Let's see, suppose the character you entered is what? Let's say you entered, let's say it's y, uppercase, lowercase y, okay? Lowercase y. You get in that character, if your word is say, right? Then the last character is y. Suppose we are there, the last one, and alt value of y is what? 121. So this would be 121. And the cipher value would be equal to 121 plus 3. That's 124, right? 124. And if cipher value is greater than ordinal value of z, and z is 122, and 124, the cipher value 124 is greater than z, than 122. So you come into this if statement, and your new cipher value will be this, odd value of a, which is 97, right? Plus distance, which is 3, that gives you 100, minus, and we need to do this, odd value of z, which is 122, minus odd value, and odd value is what? 121, right? Odd value is 121 plus 1. So that is 0, right? 122, that is 0. That gives you, 2. 122 minus 121 is 1. 1 plus 1 is 2, right? So now this is 2. So 97 plus 3 minus 2, everybody, right? That's 100 minus 2. That gives you 98. So that's your new cipher value. It's 98. And 98 converted to a character, that would be B. So if you think about it, right? Y, 1, 2, 3. Z is 1, and A, 123, 121, 22, 98, 97, 98. You come back to B. Right? That's how this works. As I said, you already have this formula. You might not need to know how that's calculated, but this is how it's calculated. If you trace it with the values, you will see it does work, right? It gives you that value. So you are coming back from here. Or you want alphabetical characters, so it comes back. That's how it works. Okay, any questions about that? This is decrypt. Decrypt is to go the other way. So once again, you get whatever the user enters, okay, and then you get the distance from the user, and then you declare this variable, assign an empty space. This is not a space, everybody. It's empty string, okay, empty. So no space. And then you do the same thing. You get the odd value and the cipher. This time, instead of add to the odd value, you subtract, because you are going back. Your encryption was to add to it, right? So your decryption is to come back, to subtract. And if a cipher value is less than this, you will do this, and you add to it. Okay, so you are coming back. So if it's less than A, it goes outside the realm of the alphabetical characters. You need to use this formula to do it. And I'm telling you, please know that the book, as well as the original slide, has an error, so I corrected it it should be this. I remember the original one was plus, but I think the digital book is okay. So you can ignore this. The original slide had a plus sign there. Okay, and then you just add to it. So let me ask you a question. Why do we have to convert it to a character, everybody? Why?
Because otherwise it would just give you a string of numbers.
Otherwise, it will be numbers. We want a text, right? We want text. We want the converted text, yes. Why do we need to get the odd value here?
Because you need a number value in that space.
So that you can do the calculation, right? So that you can add to it or subtract from it. Okay, and eventually after the for, this is all in the for loop, right? And then you print it out. Okay, this is this program. Any questions? You get the input from the user and use the for ch in n. Odd value is odd ch, that's great. Print it out. And average is odd value divided by 2. I think you misunderstood me. I'm asking you to give me the average of all the ordinal values of all the characters. Yeah, and then give me the average, and then get the character there. Does that make sense, Joe? Okay. The problem with this is, where did you get the odd value, Marilyn?
Oh, shoot. Wait, that should be CH.
But still, you don't have the odd value. You know, inside the first part is correct. You print it out. That's correct. The second part for CH in character.
Oh, it should be.
Not there.
Or...
Your second for loop for CH in character, total value plus equal to ordinal value. Where do you get that ordinal value?
From the first loop.
But you don't mind, Marilyn, right?
Yeah, I don't.
For this loop, the first loop will run completely, and then it will get out. And then the second loop, your odd value doesn't have anything. It would be, what would it be?
Oh,
It's either the last odd value, the character from the last odd value, or it's, yeah, it would be the last one, the odd value of the last one. Does that make sense?
I think so.
Yeah. So your logic is, your thinking is very good, but it's just the odd value part.
Oh, okay.
Ordinal value part, not C. Get the word from the user, and for I in word, total plus equal to odd value of I of each character, and print it out. Oh, you did the total there. Yes, that's good. Okay, and average is equal to, and you get the number of characters. That's very good. And then you do the total divided by numchar, and then print out. That's absolutely correct. That's what I wanted you to do. Brandon, let's, yeah. Okay, the average character is Z. Hello world, the average character is Z. Is that correct? Okay, is that correct? You are right. I was thinking of lowercase, and that's why I said it's impossible, because lowercase z is 122. And this, you look at this one, but it's uppercase Z, and that is correct, yes. So Omcar is counting the number of characters versus Brennan is using the len method, a function, to get the length of the string. So both ways, both ways work. Very good, very good. Thank you. It can be broken into individual characters. Okay, Python includes a set of string operations called methods that make tasks like counting the words in a single sentence easy. Okay, so if you look at this, here you're asking the user to enter a sentence, and the user enter a sentence, right? And for example, and then you can actually split. So this is a method here, split. A string is split into a list of individual words. So split, if you look at this parenthesis, inside it's empty. When it's empty, this split will split the sentence, the statement, the multiple words into individual words using space. So it will split this into a list of this sentence has no long words. Okay, that's what split does. So let's look at it. Just do an example, right? So I will just say sentence is hello world, I am here. Okay, so now you will do split, right? And this is what is, well, I changed that hello. Now it becomes more depressing. Okay, so hello world, and you notice that that period goes together with world, because when you do split, you are splitting the sentence by space, with space. So this goes with word, okay, space, and then I am here. Okay, so it prints out a list. It splits it into a list. Notice the square brackets. That means it's a list of words. Okay, that's what split is. Any questions? Okay, you can do len of s dot split, right? This will split it into everybody. This will split it into 6 words, right? And you a list, and you want to know the length of that. That gives you 5. If you count 1, 2, 3, 4, 5. Okay, and that's what this is doing. Here, print. There are len list of words, right? You are splitting it and then assign that list to this variable. For me, I didn't. I just used it directly here, right? Okay, and then you get the len of that. And then there are 6 words. Okay. So that is that. And here, look at this program. For word in list of words, remember your list of words is what? Is 6 words, right? So for each word in this list of words, sum plus length of the word. So, and then you get the sum, and then you divide it by the total length of the list, which is 6. And then you get the average. Okay, let's do that here. So let's do it here. What time is it? Let me see. 28. Why? Oh, here. Okay. Input a sentence, right? And we will do this statement. Let's see what I'm doing. We get the sum, and then we calculate the average. So why did I do that? I'm not splitting. Why did I do that? Yeah, I'm not splitting, so we don't have to do that. But just look at this. Do you understand this, everybody? Oh, that's why. I'm doing a list of words. That's why. Okay, let's do that. So list, yeah, just say L list of statement, list of words, it's better. List of words is equal to statement dot split, right? Okay, you split it, and then we want to go through each word, right? Okay, let's just print it out. CH. Okay, let's run. So I enter a sentence. Hello, you. And you can see I print it out. Hello, that's the first token, the first word, and the second one, right? Okay. This goes through each word, not each character. Okay, if you do statement here, it will go through each character, everybody. And that's the difference. Statement, okay. I will do hello, you. See, it will go through each character, right? Because this is a sentence, this is a string, this is a string. Well, here I'm changing that string, split that string into a list of tokens. A token is just a word, a cluster of words. So that's the difference, everybody, okay? List of words. So now this is a list. This list contains, what does it contain? If you entered hello, you, it will have something like this. Hello, right? And you. If that's what you entered, that would be the list. Okay. So, and when you print out, you are printing out each word instead of each character. That's the difference. Do you have any questions, everybody? See, that's each individual word there, right? Okay, now what are we doing here? We want to get the sum of the length. So we want to get the sum. Let's do the sum. Okay, we want to know how long is each word, right? Sum plus equal to length of each word. Okay, everybody, I'm doing this so that you can see that's one way, and I'm changing the variable so that you understand it better. Okay, so I'm getting the sum of each word, right? And then I want to know the average length of each word. So the average length would be average length. It's my husband. He just went on a business trip and he's coming back. I'm declining his call. What did he say? Let me see. Oh, okay. Can you give me a minute? Okay. It's very quickly. Okay. It's equal to sum divided by the total length of the list. So you can do length of list of words, right? That's the total length. So you want to do sum divided by that. And then average length is, right? Average length. Okay, let's run this. Okay, enter a sentence. How are you? And the average length is 3.3. If you look at this, each one is 3 characters, and this one is 4 characters. So that's why it's 3.3, and that's correct, right? Okay, that is how that program works, and that's how this works, everybody. Okay, any questions?